Right, we'll start with the second problem. In this problem, it is saying that estimate the cost of the earthwork for a portion of road for 400-meter length from the following data. The formation width of road is 10 meter, that is capital B. Side slopes are 2:1 in banking and 1.5 is to 1, that is 1.5 is to 1 in cutting. Right, the side slopes are different for banking and different for cutting. S is 2 in banking, S is 1.5 in cutting. Right, so that is the S values you have to take when you are doing the calculation as per the question. Right, now they are giving the station numbers from 25 station to 35 station, 25th to 35th station, and here they have mentioned the chainage distances. Right, so between 400-meter stretch, the chainage distance is 1000 at first station, second station it is 1040, third station it is 1080, like that every points are varying at the interval of 40-meter distance. Right, so if you go on varying at every point as 40-meter distance, right, at the end you will get the total chainage distance as 1400-meter at 35th station. These are the RL of the ground points. Right, so these are the RL of the points on ground at 25th station. RL of the ground point at 25th station is 51. Similarly, RL of the ground level at 26th station is 50.9. Similarly, RL of the points on the ground at 27th station is 50.5. Like this, RLs are given for all the points on the ground surface. Right, so at first station the RL of formation is varying as 52 meter. Right, at 25th station, right, at 25th station the RL of formation is 52 meter and it is varying downward in gradient. So this RL of the formation is varying as downward in gradient. Right, that is 1 in 200. Right, so this is the RL of formation at 25th station and it is downward gradient 1 in 200. So these are the information which are given in the question. Now let us try to write the cross section. So cross section of the portion in banking or filling. So this is the cross section as you have seen in the previous classes, which can be drawn in the filling. So this is the cross section which can be drawn in the cutting portion. Right, so in the question the side slope at the banking is given as 2:1 and in the cutting it is given as 1.5 to 1. Right, keeping this in mind, let us check what can be done in the longitudinal section. So this is the longitudinal section we can draw. Right, along x-axis we can draw the station points or chainage distances. Right, along this x-axis. Similarly, along y-axis we can mark all the RLs. Right, RL of the ground points and RL of the formations. Right, so start with the first station. Right, at first station RL of the ground point is 51 and RL of the formation is 52 and it is varying as 1 in 200. Right, so 1 in 200 is the RL of the formation. The variation of the RL of formation is varying as 1 in 200 from 25th station to 35th station. That means, so for every 200-meter the downward gradient is 1 unit. For every 200-meter horizontal increment, downward decrement is 1 since it is downward gradient. So decrement is 1. So we have the chainage distance as 1000 and for next chainage for next point it is 1040. That means interval between two station is 40-meter distance. Right, similarly here to here it is 40-meter distance. Right, so the gradient is varying as 200, 1 in 200. Right, for every 200 downward decrement is 1 unit. Similarly, for every 40-meter interval, how much will be the gradient decrement? Right, how much the RL of formation is decreasing? Right, for every 200, 1 is decrement. For every 40, how much is the decrement? So if you do cross multiplication, so that will be 40 divided by 200. 40 divided by 200, it will become 0.2 is the decrement. So we have to decrease the RL of formation as 0.2. right? So at first station it is given as 52, second station 52 minus 0.2, that is 51.8. Similarly, next station 51.8 minus 0.2, it is 51.6. Similarly, 51.6 minus 0.2, it is 51.4. Right, throughout the 35th stage it is decreasing as 1 in 200 only. So that is why at every RL sub formation you have to go on decreasing 0.2, right? Difference of 0.2, 0.2, 0.2 everywhere. So 51.4 minus 0.2, 51.2, minus 0.2, 51, minus 0.2, 50.8, minus 0.2, 50.6, minus 0.2, 50.4, minus 0.2, 50.2, minus 0.2, it will be 50th, 35th chain age. That is 1400 meter chain age distance, right? Similarly, we have to plot the Similarly, we have to plot the RL of the points on the ground. Right, like this it is varying. Right, so these are the given values. We can plot these values directly. Right, so by looking at this cross section, longitudinal section, we can identify at some point RL of the ground is crossing the RL of formation. Right, at some point RL of the ground is crossing the RL of formation. That means, so from here to here it is RL of formation is more than the RL of ground. But from here to here, RL of the ground points are more than RL of formation. Right. So this is where you have to decide which portion is coming in filling and which portion is coming in cutting. If the RL of formation is at higher level compared to RL of ground, so these are the portions which you have to fill. Right. So in all these portions we have to do the filling. Right. So up to this portion you have to do the filling. Right. So wherever the RL of formation is having lesser level than RL of ground points, so these portions, right, wherever the RL of ground points are crossing the RL of formation, all these points we have to, in this all this portion you have to do the filling portion. So not filling, it is cutting. Right. So if the RL of formation is more than RL of ground surface, so this is where you have to do the filling. So all these points has to be filled. Here you have to do the filling. Right, this portion has to be filled, and this portion has to, we have to do the cutting here. In all this portion you have to do the cutting, in all this portion you have to do the filling. Right. So the portions which are coming over the RL of formation, so this portion has to be filled, and this this portion you have to do the cutting, and in this portion you have to do the filling. So this is filling where RL of formation is more than RL of ground. So here these points are, RL of formations are lesser than the ground points, so this portion has to be cut. Right, now so you have to carefully observe between these two stations. Right, station number at this station and at this station, where change distance 1200 to 1240 between these two stations. So we are getting both cutting and filling. Right, here you have to decide how much portion is coming in filling and remaining how much portion is coming in cutting. Right, we can calculate the depths at this point. Right, 51.00 minus 50.7, so that depth is 0.3. Similarly, 51.2 minus 50.8, that depth is 0.4. Right, so based on these depths we can identify so how much portion. Right, at this point the D becomes 0. Right, where RL of formation crosses the RL of ground. So this point, this is the point where T becomes 0. Right, so here we can get the depth as 51 minus 50.7, right? So this portion we can get depth as 0.3. Similarly, here it is 51.2 minus 50.8. So that point we can get depth as 0.4, right? In between these two, the point where RL of formation crosses the RL of ground, at that point the depth will be 0, right? So before it comes as 0, so it will be having some portion here up to this. So this is where we have to do the filling, right? So how much we have to do the filling and how much we have to do the cutting. To decide this value, we need to understand how much is the length which is covered in filling portion, how much is the length which is covered in cutting portion. That we have to calculate, right? So that is calculated here like this. With this, using these similar triangles, at 1200 chain edge distance, we have the depth as 0.3. At 1240, we have the depth as 0.4. Difference of RL of formation minus RL of ground points, right? So at this depth, the D will become 0 at this point, right? So before it comes to 0, how much is the X distance which is coming in filling, and after it becomes 0, so how much is the portion which is coming in cutting between these two stations, 1200 and 1240, right? Out of this 40-meter length interval, so some of the portion is coming in filling, some of the portion is coming in cutting. So how much portion, how much length is coming in filling, how much length of this is coming in cutting, that has to be calculated using similar triangle technique. That is, so we can use for 0.3, x is the distance. For 0.4, so 40 minus x is the distance. Using this calculation, we can get x is 17 meter. That is, out of 40 meter, 17 is coming in filling, remaining is 23. So this 23 is coming in cutting. So that you have to calculate, right? This is the 23 which has to be used for multiplication of cutting portion, right? So this x is 17 meter which is coming in filling, right? That means up to 1200 meter distance it will be filling, right? So from 1200 to 1270, including this 70 meter, right? So 1270 here will be having filling. From 1270 to 1240, so this will be coming in cutting, right? This is will be coming in cutting, and this will be coming in filling. This portion will be coming in filling, right? 1200 to 1270, so that is in filling. 1270 to 1240, that is in cutting. So that is what we have to understand, and you have to take care when you are doing the calculation, right? Here you can see, right, from 1000, so at 25th station the change distance is 1000. Like that it will vary. At 30th station the distance will become 1200, right? At 31st station distance is 1240. In between we have the depth 0, that is where RL of formation is crossing the RL of ground surface, right? 1200 to 1217, so this is coming in filling. 1217 to 1240, that is coming in cutting. So from 1200 to 1217 we have the 17 meter length which is coming in cutting, right? From 1217 to 1240, that is 20 meter which we have calculated, that is it is coming in cutting. So these are the interval distance has been divided, right? Out of 40-meter distance chainage interval, right, this total is 40. This total is 40. Out of this 40, so 17 meter is coming in filling, 23 is coming in cutting, right? So this way you have to do the calculation properly. Now we can calculate the depth. Depth d1 is calculated as RL of formation minus RL of ground. Like that you can go on calculating the depth for every station. So depth at first station is 1, at second station is 0.9, and at third station is 1.1, and at fourth portion is 0.6. Similarly here also it is 0.6. At 1200 meter it is 0.3, and when it comes to 1270, that is where the RLF formation crosses with the RLF road. At that point the depth will be 0, right? From that 0 to next station, that is the 1240 station, so it will be 0.4, right? Like that you can go on differentiating, getting the difference between RLF formation to RLF ground for remaining points. So these are the depths we can calculate, right? Now we can take the average depth. Average depth we can calculate 1 plus 0.9, that is 1.9, right? 1.9 divided by 2, so it will become 0.95. Similarly, you can calculate average depth, 0.9 plus 1.1 divided by 2. Similarly, you can calculate average depth 1.1 plus 0.6 divided by 2, like that. Similarly, when it comes to here, it is 0 plus 0.3, 0.3 plus 0 divided by 2, so that is 0.15. But when it comes to here, 0 plus 0.4 divided by 2, that is 0.2. Like that, it will go on continuation, right? It will go on continuation. Like that, you can calculate the depths, mean depths, right? Once mean depths are calculated, so we can calculate the b into d portion, rectangular area portion, area of the central rectangular portion, that is b multiplied by d. So here b is, capital B is 10 meter, formation width is 10 meter, 0.95 multiplied by 10 is 9.5. Similarly, 1 multiplied by 10 is 10. Like that, multiply all the formation widths for mean depths, so we can get these values. Next, when you are calculating side areas, that is SD square. This is SD square, where S is the side slope. Right, wherever you are getting filling, that portion we have to multiply with 2. Wherever you are getting cutting, right? So you can see that from this next, from next point from the 0. So these are all the portions which we are getting as cutting. For all this cutting portion, we have to multiply the S value as 1.5, right? So 1.5 multiplied by d square, right? For above portions, we have to multiply with the 2. So side slope for filling portion is 2, which you can see here. In the cross section, you can see that side slope for filling portion is 2, side slope for cutting is 1.5. So these S values you have to use carefully when you are doing the area calculation for filling and area calculation for cutting, right? Up to this value, you have to multiply S as 2, right? So from here to here, you have to multiply S as 1.5, right? So up to here, S is 2, right? From here to here, S is 1.5. That is 2 multiplied by average depth square, 2 multiplied by 0.95 square, 2 multiplied by 1 square, right? Similarly, 2 multiplied by 0.85 square, right? So up to here, you have to multiply S as 2. From here, it is 1.5. So this is where our S varies, right? Once ST square is calculated, BD is calculated, add these two, BD plus ST square on both sides, BD plus ST square on both sides, add this, we can get this total area of the trapezoidal portion. Next, multiply this total area with the interval distance between first station to second station. So that is 40 meter, right? When it comes to 1200, so from 1200 to 1217, the distance is 17 meter. 1217 to 1240, the interval distance is 23, right? When you are calculating this value, when you are calculating this value, so the total area 1.545 multiplied by 17, so that will give 21.26. Check this value, it may be around 26, right? Similarly, when you are calculating this 47.38, so this is obtained by multiplying 2.06 multiplied by 23, right? So this is where you have to observe the interval distance between 1200 to 1217 is 17 meter. Similarly, interval distance between Similarly, interval distance between 1270 to 1240, that is 23 meters. Right, multiply this 23 meters to 2.06, that is where you can get 47.38. right? So remaining all calculations we have to multiply with 40 meter, right? So from now onwards we have to multiply 40 meter for all calculations till the end, right? For all the calculations you have to multiply the 40 for remaining calculations, right? 6.54 multiplied by 40, it will get 261.6. 9.583 multiplied by 40, you will get this value. 9.583 multiplied by 40, you will get this value. 7.735 multiplied by 40, you will get this value. Now we can add filling portion and cutting portion of the value separately, right? Add all these values, we can get the 1816.265 as the filling. Add all these things, we can get the portion is cutting, right? So from this 0 point onwards, right? From this 0 point onwards up to this 0 point, we are getting filling, right? From this 0 point onwards, we are getting cutting, right? So add these values separately. You can get the value of filling and cutting. Now we have to multiply the rates. The rates for filling is 275% per cubic meter. That is 2.75 rupees per 1%. So multiply 1816.265. This year you can get this rate. Similarly, multiply by 350 rupees per percent per cubic meter. That is 3.5 rupees per 1%. Multiply with this value. We can get these two rates. Add these two rates, right? For this rate, add 5 percentage of work establishment and contingencies, that is 492.11 rupees, right? Total will be 10,334.4 rupees for the completion of cutting and filling. So this is the total calculation of filling and cutting in the same problem.